Okay, so I'm just going to review, in fact, 3 problems from homework number 42. They're all on the answer key that I'm sending with this video, but here I'm just going to work 3 of them out just so that you have them, me talking them out and explaining them to you. But every single problem from the homework is worked out in detail on the answer key. I encourage you to check your answers on your homework with the answer key to make sure you have them correct, and if and learn how to do anything that you don't know how to do by looking at the answer key. Okay, here we go. First problem, 5 root 8 minus root 32 plus 2 root 18. Okay, first of all, we need to simplify these radicals. That's what we've been talking about, simplifying radicals. So the 5 just stays where it is out front. Square root 8, remember, square root pretty, square root ugly. What's pretty about 8? 4, remember, perfect square number, 4, right? And 2 is what's ugly, leftovers. 4 is the biggest pretty number sitting inside of 8. 2 is the ugly number. Pretty, ugly, multiplies to be 8. Okay, next step. Root 32 is going to be root pretty, which is 16, because 16 is the biggest perfect square number inside 32, times root ugly, which is 2. And then finally, plus 2 times root pretty times root ugly. What's pretty about 18? It would be 9. What's ugly? It would be 2. So there's the original breakdown. Now, remember, when we're doing square root pretty, square root ugly, like we got here, the pretty one always simplifies. That's why it's pretty, because it'll simplify. So, square root 4 is 2, right? Square root 16 is 4. Square root 9 is 3. All of the pretty guys simplify to these numbers. So, 5 times 2 times root 2 is going to be 5 times 2 is 10, 10 root 2. Okay? Minus 4 times square root 2 is 4 root 2. Plus 2 times 3 is 6 times root 2 is 6 root 2. And oh my gosh! Oh my gosh! Oh my gosh! I can't believe it. Look, es lo mismo, every single one of them is exactly the same under the radical, meaning they can be squeezed together. It didn't look like it. It looks like, nope, they're all different. Nothing squeezes together, but guess what? They do. 10 minus 4 is 6, plus 6 more is 12. So it's all 12 root 2. Cha-ching. There you go. All right, so that's that problem. Similar idea with all these problems, okay? So we're gonna simplify. You might say, oh, they all are different. Can't combine them together. Well, we don't know that. We have to figure this out, okay? We're gonna go square root pretty times square root ugly, right? What's pretty about 48? Well, 6 times 8 is 48, but guess what? Neither one of those is a perfect square number, so that's not what we're talking about. We're talking about the biggest perfect square sitting inside of 48 is called 16, because 16 times 3 is 48. So 16 is pretty. What's ugly? 3. P, square root P. What's pretty about P? Nothing. It's flat out ugly. So it gets P, right? Plus 3 times root pretty, root ugly, okay? What's pretty about 18? It's gonna be 9. What's ugly? 2. What's pretty about P? Kind of like my brother. Ain't nothing pretty about it at all. Flat out ugly, okay? Minus 2 root pretty, root ugly, okay? Root 27 is 9 is the 9 is the prettiest number that goes into 27. Times 3 is the ugly number, and then P is left over. And oh my gosh, can you believe it? Oh, I was going to say they all have root 3P, but they don't all have root 3P because this one has a 2P. So we'll see what happens when we simplify in the next step. But here we go. Root 16 is 4. Root 9 is 3. Root 9 is 3. Every one of the pretty guys always simplifies. So here we go. 4 root 3P. Okay, plus 3 times 3 times root 2p is 9 root 2p, and then minus 2 times 3 is 6 times root 3p. Now, not like this one that had they all were root 2. These guys are similar terms because they both have 3p under there, but this guy is not. So this guy will not combine with the other two. So we combine these two. 4 root 3p minus 6 root 3p. That's going to be minus 2 root 3p. And then this guy's left over plus 9 root 2p, right? So that is a correct answer. You could have it flipped around as 9 root 2p minus 2 root 3p. Either one of those is a fine answer. It doesn't matter. You can put it this way or you can put it this way. Either answer would be correct. Okay, finally, let's do this one. So, same idea. All of this stuff is the same idea. 2, root pretty, root ugly. What's pretty about 75? 25. Remember, 3/4, 75 cents. What's ugly? 3. What's pretty about m? Nothing. So there we go. Minus root pretty, root ugly. What's pretty about 12? 4. What's ugly? 3. And then m is all ugly. It goes on the ugly side. Minus root pretty, root ugly. What's pretty about 108? Wait a minute, 108. You might say this. You might say, this is not what I would do, but you might say 9 is pretty because it's root 9 times root 12. And that is actually correct. There is a 9 because it's 9 times 12. But the problem is 12 also has a pretty, look, 12 could be root pretty, root ugly, right? Root 4 times root 3. There's another pretty number sitting inside of 12. So that's the reason you don't want to use this. 9 is a pretty number that sits inside of 108, but it's not the biggest one. In fact, the biggest one, look, if 9's pretty and 4's pretty, then 9 times 4, which is 36, also sits inside of there. And it is, it's 36 times 3. So I would not break it up into root 9 times root 12. I'd break it up into root 36 is the pretty, 3 is the ugly. And then m is left over there, okay? So either way, you could do it this way. It's just going to take one more step. Okay, now, these should all the pretty ones should be nice numbers. Look, square root 25 is 5. Square root 4 is 2. Square root 36 is 6. Now, let's see what happens here. We're going to get 2 times 5 is 10 root 3m. 10 root 3m minus 2 root 3m minus 6 root 3m. Can you believe it? I cannot believe this. Look. Holy mo, how could that, oh yeah, it came from a textbook, that's why. Okay, would that ever happen in real life? Not a chance. Okay, but just enjoy it. 10, take away 2 is 8. Take away 6 is 2. So it's going to be 2 root 3m. There you go. Cha-ching.